Hello everyone, here's an alternative method for deriving the formula for R in the compound interest formula. I had already uploaded the first method, and that is using the natural logarithm to isolate the R in the formula. If you haven't watched that video yet, just visit my YouTube channel and look into my video list. Okay, so this time I'm gonna use common logarithm to isolate the R. Okay, so let's start. So initially we start with the general formula for compound interest. A equals P times the quantity 1 plus R divided by N raised to the exponent N times T. Okay, so still the goal is to gradually isolate R by itself on the right side. So the first step is the same as the first step of the uploaded video, and that is elimination of P from the right side. Okay? So how to eliminate P from the right side? Divide both sides by P. A divided by P, right side divided by P. So P is cancelled. Okay, so the right side becomes the exponential expression. 1 plus R divided by N raised to the exponent N times T. Okay? Next target is to be able to write the exponent Nt in front of this expression. So to be able to do that, I will use rules for logarithm. So I'll take the logarithm of both sides and I'll use the common logarithm. Common logarithm. I had already used the natural logarithm, so this time I'll use the common logarithm. Common logarithm is base 10 logarithm. So I'll take the logarithm of the quotient on the left side and the logarithm of the exponential expression on the right side. Okay, on the left side, I can use the quotient rule for logarithm to expand the logarithm of the quotient. Okay, so what is the quotient rule for logarithm? It says that the logarithm of the quotient of numbers is equal to the difference between the logarithm of the individual numbers. So we take the logarithm of the numerator less logarithm of the denominator. So it's the application of the quotient rule for logarithm. Okay? On the right side, I'm going to use the power rule for logarithm. The power rule for logarithm says that the logarithm of an exponential number or logarithm of an exponential expression is equal to the exponent multiplied by the logarithm of the base. So this exponent N times T can now be written in front, and you multiply it by the logarithm of the base. Okay, next, I want to get rid of NT from the right side. So I'll use the opposite operation of multiplication to cancel out NT. Divide both sides by NT. Right side becomes logarithm of 1 plus r divided by n. Left side becomes logarithm of a minus logarithm of p divided by n times t. Okay? So, by default, common logarithm has a base 10. And it's usually omitted. So, there's an invisible 10. So, I'll write it down. I want to cancel this on the right side. And to undo the logarithm to base 10 on the right side, I'll place base 10 to both sides of the equation. This will undo the logarithm to base 10 or the common logarithm. Okay? So, the left side becomes 10 raised to logarithm of a minus logarithm of p divided by n times t equal to 1 plus r over n. Then, I want to eliminate 1 from the right side. So, I'll just have to subtract 1 from both sides of the equation. So, left side minus 1. Right side minus 1. Okay, so 1 is cancelled. The right side becomes r divided by n, and the left side becomes 10 raised to logarithm of a minus logarithm of p divided by n times t minus 1. Last but not the least, clear the denominator. So we multiply both sides by the denominator. Times n. Okay? So the right side becomes r. And it's equal to n times the quantity 10 raised to logarithm of a minus logarithm of p divided by n times t minus 1. This is the derived formula for r. So if you're solving word problem involving compound interest and r is required, you can use this formula to solve for r. Okay? So if you have questions or you want clarifications, feel free to use the comment box. Again, please don't forget to subscribe to my YouTube channel. It's Tutor Marife MCP. Thank you for watching.